Hello friends, welcome to the YouTube channel of Chameli Devi Institute of Pharmacy, Indore. In today's session, we are going to discuss about surface tension and interfacial phenomena. Now, let us start with the interface. What is an interface? In the physical science or pharmacy, an interface is the boundary between two spatial regions occupied by different matters or by the matters in their different physical states. The interface between matter and air or matter and vacuum is called as surface, and the study comes under surface science. In thermal equilibrium, the regions in contact are called as phases, and the interface is called as phase boundary. As shown in the diagram, air liquid system, the interface boundary is shown by dark line. Next, what is interfacial tension? The interfacial tension is the force of attraction between the molecules at the interface of two liquids. The SI unit of interfacial tension is millinewton per meter. These are equivalent to the former units of Dyn per centimeter. Now coming to the next, surface tension. The surface tension is a phenomena in which the surface of the liquid is in direct contact with the air. The surface tension can also be defined as the force acting at right angles to the line of unit length present in the surface. The surface tension is usually denoted by gamma. As we all know that work done is equals to force into distance, therefore the surface tension can be given as force upon distance. The SI unit of surface tension is Newton per meter or Dyn per centimeter. The surface tension of a liquid is the energy required to increase the surface area, which increases the stability of the solution and increases the solubility rate. As shown in the figure, a molecule is floating on a liquid surface whose weight is acting downward and the surface tension force is acting on the molecule. The molecule present on the surface is having a force acting on its lower surface, while the molecules are in the liquid surface are having the force acting all over the surface. Next is there are some examples of surface tension. First is walking on water. A small insect such as water strider can walk on water because their weight is not enough to penetrate the surface. Second example is floating of a needle. Third, surface tension disinfectants. Fourth, soaps and detergent. Next is surface tension and droplets. Now next is surface tension at a molecular level. In general, the water molecules want to cling to each other. At the surface, however, there are fewer water molecules that can cling due to air present above them. This results in a stronger bond between those molecules that actually comes in contact with one another. As shown in the figure, a layer of strongly bonded water molecules, the surface held together by the surface tension creates a considerable barrier between the atmosphere and the water. Within the body of the liquid, a molecule will not experience a net force due to the force exerting by the neighboring molecule cancel out each other as shown in the figure. However, the molecules on the surface of the liquid will experience the upward force as well as the downward force. The inward force causes the molecule on the surface to contract and to resist being stretched or broken. Thus, the surface is under tension. This is the probable name the surface tension comes from. The next is the surface tension of water at different temperature. The table is showing the effect of temperature on the surface tension. A graph is plotted between the surface tension of water and the temperature. It is also showing the variation in the surface tension with the increasing of the temperature. Now, the next is measurement of surface tension. How the surface tension can be determined. The first method is capillary rise method. This is the oldest method for the determination of surface tension. The consequence of surface tension appearance at liquid-air interface in moving up of the liquid into a thin capillary tube, which is usually made up of glass. This phenomena is applied for the determination of surface tension. For this purpose, a thin circular glass capillary is dipped into a tested liquid. If the interaction forces of a liquid with the capillary wall, that is the force of adhesion, are stronger than the force of cohesion, the liquid weights the wall of the capillary and the water level or the liquid rises into the capillary up to a defined level by forming the meniscus, which is hemispherically concave in nature. In contrast or opposite situation, the forces causes the decrease of the liquid level into the capillary below that in the chamber, and the meniscus is semispherically convex as shown in the figure A and B. If the cross section area of capillary is circular and its radius is sufficiently small, then the meniscus is semispherical in nature. If the cross-section area of capillary is circular and its radius is sufficiently small, then the meniscus formed is semispherical. Along the perimeter of the meniscus, there acts a force due to surface tension present, which is given by F1, that is equals to 2 pi r gamma cos theta, where r is the capillary radius, gamma is the surface tension, and theta is the wetting contact angle. The force F1 in the equation is equilibrated by the mass of the liquid raised into the capillary up to a height h, that is the gravity force, which is given by F2 equals to pi r square into h into d into g, where d is the density of the liquid and g is the acceleration due to gravity. In equilibrium, F1 is equals to F2, which is given by 2 pi r gamma cos theta equal to pi r square h dg. On rearranging the equation, gamma equals to r h dg upon 2 cos theta. If the liquid completely weights the capillary wall, that is the contact angle is 0, that is cos theta equals to 1, in such cases the surface tension is equals to gamma equals to r h dg by 2. The next method for the determination of surface tension is drop volume method or stallometric method. If the volume of the drop or the weight of the drop as it is detached from the tip of a known radius is determined, then the surface tension or interfacial tension can be calculated from the following equation. Gamma equals to psi mg upon 2 pi r equals to psi into V rho g upon 2 pi r, where m equals to mass of the drop, V is the volume of the drop, rho is the density of liquid, r radius of the tip, g acceleration due to gravity, and psi is the correction factor. The correction factor is required as not all the drops leave the tip on detachment. The tip must be weighted by the liquid so that the drop does not climb to the outside of the tube. Now, the next method for the determination of surface tension is Wilmy plate method. This method was elaborated by Ludwig Wilmy. In this method, a thin plate made up of platinum or glass is used to measure equilibrium surface or interfacial tension at air-liquid interface or liquid-liquid interface. The plate is oriented perpendicular to the interface and the force exerted on it is measured. As shown in the figure, the plate should be cleaned thoroughly and it is attached to a scale or balance by a means of thin metal wire. The plate is moved towards the surface until the meniscus connects with the liquid. The force acting on the plate due to its weighting is measured by tensiometer or microbalance. To determine the surface tension G, the Wilmy equation is applied. If the plate is having a width of L and its weight is W, then the force F needed to detach it from the liquid surface equals to W total equals to W plate plus 2 into L into G cos theta. Multiplying the equation by 2, as the surface tension is acting on the both sides of the plate whose thickness is neglected. When the weighting angle is 0, that is cos theta equals to 1, the surface tension is given by gamma equals to W total minus W plate upon 2 into 1. The accuracy of this method reaches about 0.1% for the liquids that weights the plate completely. Now, the next method for the determination of surface tension is ring detachment method or Dunois ring tensiometer. As in the previous method, we have used the platinum plate. Here, the platinum ring is used instead of platinum plate. As the ring is pulled out of the liquid, the force required to detach it from the surface of the liquid is measured, and the force related to the surface tension is measured. The platinum ring should be very clean without blemishes or scratches because it can alter the accuracy of the results. The total force needed to detach the ring equals to the ring weight and the surface tension multiplied by 2, as it is having a 2 surface circumference on the rings. The formula for determination of total force is given by Wr plus 4 pi r gamma or equals to Wr plus 2 into L into gamma, where r is the ring radius. It is assumed that the inner radius and the outer radius are equal. Next is application of surface tension and interfacial phenomena. First, adsorption of drug on the solid adjuncts in the solid dosage forms, penetration of molecule through biological membranes, formation of emulsion and the stability of emulsion, the dispersion of insoluble particles in the liquid media to form suspensions. The surface tension also play an important role in dirt cleaning. Thank you.